So let's take up the knowledge check. So, identify the element that lives in group 2 and period 3. Alright, so now I've got my textbook here. Let's see. Here we go. That's periodic table. So, group 2, period 3. Remember, these are groups going down. These are periods going this way. So, group 2 is here, and then period 3 is here. So this would be our magnesium. Okay? Oopsies. Sorry, can't see that. Group 2, and then period 3. So it would be magnesium. Okay, that would be your answer, that one. Period 4 and has 7 valence electrons. Okay? So remember, so we're going period 4, right? And then it has 7 valence electrons. I guess showing you now the trick of the valence electron. These guys all have 1, okay? These guys all have 2. So that's period 4, right? Yeah. Transition metals are a funny group. We don't usually do Bohr-Rutherfords or Lewis dot for them because there's tricks to them, right? But here, these guys end up having 3. These guys have 4 valence electrons. These guys have 5. These guys have 6. These guys have 7. And then, for the one that's in period 4, that's bromine. Okay? Remember, these are families too, right? And their families are based on similar characteristics, and it's their valence electrons that give them those similar characteristics. So keep that in mind. How many electrons are allowed in the second energy shell? Right? So our shells, it goes, what we teach you is it's 2 in the first, 8 in the second, 8 in the third, and then we don't go past ones that have 2 in the fourth because, again, it gets to these guys, the transition metal guys, and there's a different trick to how they put their electrons in their shells, and you won't get into that until grade 11. What is a chemical property that is shared by all alkali metals? Well, alkali metals are those, that first family here, not hydrogen, because it's not a metal. But these guys are all alkali metals. And these guys are all very reactive with water. And Mythbusters does a video on the internet if you have time, and it's like a 5-minute video, you want to watch it. And it shows you these 3, it shows you these ones, and it shows you how explosive they can get. The further you go down in the family, the more reactive with water they are. Alright, so write the Lewis symbol for nitrogen, okay? So we have nitrogen, remember, so the Lewis dots. So nitrogen has 7, its atomic number is 7, right? So in the first shell it would have 2, and then in the second shell it would have 5. So then the Lewis dot for nitrogen would be 5. Or I would have done it like this, usually. It seems more even when they all actually have 1 on each side. But it doesn't matter, 5 or 5. And then iodine. And again, you can't do a Bohr-Rutherford for iodine because you guys wouldn't know how the electrons laid out because its atomic number is 53. But knowing what group it's in the family, you know that it will have 7 valence electrons. Okay? Initially, 2 or more elements were placed in the same group of the periodic table because, I just told you, because of their valence electrons. How many neutrons does uranium have? So, looking up uranium on the periodic table, or I guess in your case, a lot of you guys would have just Googled it. Okay, so uranium, hopefully, like I'm sure most of you would have just Googled it, but it's at the very bottom there. So uranium's atomic number, let me just write this down, is, 92, okay. And then its mass is 200, and we always round. I don't know if I told you that, sorry, 238. We'll always round up or down with that one, okay? So, atomic number is 92, mass is 238. Okay, so you're going to take 238 and you're going to subtract 92. Remember, the rule is the mass, because the mass is the nucleus, and all whatever's in that's where all the mass is, and then the nucleus holds the protons and the neutrons. So we have to subtract how many protons there is to figure out how many neutrons are left over. Okay, so that's 238, subtract 92, and you're going to get 146. 146, and that's how many neutrons would be left in the nucleus. Okay, which section of the periodic table contains elements that can conduct electricity, and then some gaseous elements? Right. Well, elements that conduct electricity are, and just by looking at it, and if you were reading them, you would have figured out, like, you have your, copper, your nickel. So that's here, transition metals, right? So which part of the periodic table? Well, that's the middle, the transition metals. And then your gaseous elements, in the textbook, and you guys don't have the textbook, but any of the symbols, so these are the symbols, right? The letters that represent the element. Any of the ones that look like this, here, see how it's not filled in? This one's black and this one is just an outline. These ones are all gas, okay? And then all the ones that are black are solids, and that means at room temperature. So if you were to look, I'm just going to bring it up here and look, right? These ones are all solid at room temperature, okay? You have hydrogen, which is gas at room temperature, and then here, over here is all gas. So you could say the non-metals for that one, or the noble gases, because again, they're all gases. Either or, just understanding where the gas ones are, which is up here, okay? And then where we have all the metals over here, okay? And then the last one is, the following diagram is drawn to show the electrons in boron. What is wrong? So it has the nucleus there. It has 2 electrons. But you can see it. I'm just going to redo it. So boron has 5 protons, 5 electrons. Remember, our proper Bohr-Rutherford, though, we always state the protons and the neutrons in the middle. And then you would do the electrons. Okay, so in this case, it has 1, 2, 3 shells, but it would only be 2 for boron. Okay, that's the knowledge check.